So first of all, hey everybody, thanks for joining this week's Tech Talk. Really excited. We have a fun one for you today. My name is Brad Monday, machine learning engineer here at Modzy. And today I'm excited to walk you through our Tech Talk where we'll explore how to run a Hugging Face model on a Raspberry Pi. Before we get into the fun stuff, wanted to give you a look at what's ahead. So next month we'll have a great talk about what is model serving? So introducing all the technology that goes into serving models, which is really relevant for ML ops and a big buzz today. And then that will close out the calendar year, and looking into next calendar year, let us know if you have any ideas. We're noodling on a couple of different Tech Talk topics, but always interested in hearing our feedback. Okay, so how did we come up with this idea of a Tech Talk to combine Hugging Face and Raspberry Pi? Well, here at Modzy, we've got a collection of really passionate data scientists who love the Hugging Face community, love the platform, in addition to computer engineers, computer scientists who have done some pretty awesome projects with Raspberry Pis. And given the nature of Modzy's edge capability, one of the features of our platform that we focus on a lot, there's lots of experimentation, and Raspberry Pis are kind of a natural fit for that. So what we thought we'd do is build a pretty cool demo and solution that combine these two communities, and show you what that might look like. So we've done some research, and ahead of time, I found that really nobody's trying to solve this problem. I found one entry about running an ASR model on a Raspberry Pi, and even that that forum didn't prove to be very valuable. In addition to Stack Overflow, not a whole lot of people looking into this. So what we thought we'd do is, again, kind of combine these two. It's pretty cool, in my opinion, to look at these different platforms, and we've got Hugging Face on the left and Raspberry Pi on the right. Their logos just happen to be these very fun emojis, and to introduce a third cliche emoji into the picture, we'll bridge the gap with this handshake. So Hugging Face meet Raspberry Pi, and the objective today, as I mentioned, is just to provide a solution that allows you to kind of run this analysis. So before we dive into the demo, wanted to provide a very quick background. So on the emoji theme, I saw an article the other day that from Forbes that called this the $2 billion emoji. And it discussed the idea that Hugging Face has garnished such a wide adoption, and they're now starting to monetize that and being very successful in doing so. But for those who maybe don't know what Hugging Face is, it's an open source community and platform that gives data scientists and machine learning engineers the tools to build powerful AI applications. And moreover, their mission is to democratize AI through open source and open science. Looking at the platform itself, I talked about that widespread adoption. There's well over 25,000 users today, over 60,000 total models that anybody can go download at any time, 6,000 data sets, and endless fun. As a data scientist myself, I love working with Hugging Face and building cool things and being able to see the different models that are accessible to everybody. So needless to say, here at Modzy, we are big fans of Hugging Face. Moving on to Raspberry Pi, an equally as awesome community and organization. For those who don't know much about Raspberry Pis, there's these very small single board computers introduced by the Raspberry Pi Foundation back in 2012. And their main mission is to make computing education more accessible to everybody. And they've done so through these very small computers that are accessible. Since inception, they've built 13 different models that have different infrastructure footprints, ranging from a single CPU core with 250 megabytes of RAM to a little bit larger of a model that has 4 cores and almost 4 gigs of RAM. They're extremely accessible, as I mentioned, with low cost, on average about $35. And as a result, there's so many different things that you can do with Raspberry Pi. There's a ton of utility for electronics testing and experimentation, in addition to IoT experiments. And there's really just a ton of application and a lot of cool projects we've seen built from Raspberry Pis. just to show you what a quick picture looks like, right? They're very small. This is the 3B model that we're actually going to be using today. What's also great about Raspberry Pis is they come with these GPIO pins that allow you to connect different pieces of technology and build cool projects and solutions. So these pins, you can connect lights, you can connect sensors, cameras, microphones to collect all different types of data and again build fun projects and solutions. And before we get into the demo and the solution itself, I would be remiss to not mention Modzy's very own Edge Device Service Hub, hosted courtesy of Seth Clark at his house. He's our head of product here at Modzy. And what we're seeing here are 4 of the edge devices that our team experiments with quite frequently when we're working with our edge solution. So on this board are 2 different Raspberry Pi models. In the bottom right is the model that we'll be hitting today. And there's a UP board and also a Jetson Nano from NVIDIA. So just to show you what this looks like, this is a real live live picture, and we're going to be interacting basically with this bottom right. Okay, now as we get into the solution before the demo, right, the fun stuff, I wanted to just kind of lay out what we've done and how we built this. And to do so, it's important to understand 2 different environments we're working with. The first is just a Python environment that I'm going to be running on my computer, and we'll do so in a Jupyter notebook. And then the second is that Raspberry Pi device that I mentioned, that machine that's sitting at one of our team members' house. So for all intents and purposes, let's think of that as a remote environment today. And we'll be communicating again from my machine to that remote environment. So the first thing we'll want to do is download a model from Hugging Face, and we'll show you how to do that. And then to take it from that the Hugging Face file state to a Raspberry Pi, what we're going to do is introduce a Python library called chassis.ml that will build a container out of it. This container will then be very portable, it will be immutable, and most importantly, interoperable. So we can run this container in a variety of target architectures and environments, including Raspberry Pis. So from there, we'll introduce 2 different ways that you could actually take this container and deploy it and run it and serve it on this Pi. The first route we'll use Docker directly to simply pull the container, download it, spin it up, and then start running it. And then we'll leverage gRPC to generate some Python code to communicate with our container. Now, some of you may be familiar with REST and building REST servers and making REST API calls to containers. In this scenario, we're going to be working with gRPC for a variety of reasons. But fortunately, Chassis takes care of all of that for us. And so again, what we'll be doing is generating some client-side gRPC code to communicate directly with our Docker container. And then the second fork and avenue we'll explore is doing this exact same thing with a COT solution, in this case, Modzy's Edge solution. And what that will do is deploy and serve this model container directly on the Raspberry Pi or any Edge device. We'll be able to leverage Modzy's APIs to consume that model. And then finally, this is really applicable for lots of reasons. But if you ever needed to scale this solution or this model to not just 1, but tens or even hundreds of Raspberry Pis, you could do that with Modzy very easily. And what I'm pulling up now is my Hugging Face browser. Can somebody verify that you can see my browser instead of the PowerPoint?
Yep, looks good.
Cool, thanks, Seth. So kind of following that demo flow that I just described, the first thing we're going to want to do is find a model in Hugging Face. Now, if you've never visited the Hugging Face site before, it's a great interface. Let's go to the Models tab, for example. And what you can see is this full library. Again, there's over 60,000 models that you can just pull down from the hub and use that span all different tasks, data types, libraries, etc. So let's search for one particular one that we're going to use. Let's see here. And this is actually a transformer, one of the types of models that made Hugging Face really explode back in 2019 as they democratized all these different transformers and variations and centralize them for all data scientists to work together and share. So, so this particular transformer, or the tiny BERT model we're using, is very small, intentionally, right? Because we're working with a target device that has very, minimal infrastructure resources. So anyway, that's the model we're going to be deploying. It is a text classification model, so it will return basically emotion classes and predictions on text, which may not be the most applicable, edge use case, but the purpose of this is just to show how you could basically replicate this and do this yourself. And then we might want to explore additional use cases for audio-based models or image-based models, things down the road. So what we see here is a model card. You'd see this for every model in Hugging Face. You could even run sample inferences here. But what we're interested in looking at is how to actually use this models with the Transformers library, which is a really, really, really useful tool. So what we see here out of the box is some copy-pastable code. We will copy this and then move over to this notebook and walk through this flow. Now, before I keep going, it's important to know here that I'm going to show lots of code snippets. A lot of it will be driven from this notebook, but also included in the demo will be a kind of a custom application. All of this code will be included in a GitHub repo that we'll include on our YouTube channel when we post the video after the fact. That will have extensive instructions if you want to replicate this yourself. So in this notebook, some instructions up front. What I'll then do is import the packages I'm going to need. And so basically what I've done is modified that code directly from Hugging Face to download our model. So what we see here is we download both the tokenizer and the model itself locally. And then what we can do is save that using the save pre-trained function from the Transformers library. And then just using some of the Transformers code here, we can run the model and see what the output looks like. In this case, the model developer did some mapping and renamed the emotions dataset classes to label 0 through 5. And what we'll do later is some mapping of those classes. So we can see how the model runs with just some sample data. Looking forward to going skiing this winter, and this is what the output looks like. Now it's time to introduce chassis, right? So we've got this model in Python, we've saved it to my local desktop, and it's time to build a container out of it, which is really important when you think about the mechanisms of how we're going to take a Python file and deploy that, serve that, consume that on a remote device, in this case a Raspberry Pi. So one of the first requirements in chassis is to load the model into memory. So we're going to do that from the location that we've saved this, right? And generate some custom label mapping. And then the idea behind chassis, and again, I'll go through this quickly, but if you were to go to chassis.ml, it's our home documentation site for this open source package. And following any of these how-to guides, the idea is that you basically just need to get your model loaded into memory and define a couple functions. So feel free to check this out yourself for more details of how it works, but I'll go through this part relatively quickly. So again, I've got my model loaded. I need to define my single process function. The idea behind this is an inference function. So it takes in some data, I'll decode the raw text bytes and send that through our tokenizer for pre-processing. And then once that's complete, we'll pass our tokenized input through our model, apply a softmax layer for more human readable outputs, and do some post-processing. Once I've done that, chassis will do the rest. And so the first thing I need to do is instantiate my connection to the chassis service. It is a Kubernetes service. We have a publicly hosted version that we're connecting to right here. We'll create a chassis model object out of that process function and run a sample test. And what we see out of the box is that the output looks as expected. Again, very similar to running this, just with the Hugging Face code. Then I can define a conda environment where I can specify the specific Python libraries and dependencies that my model will need to run inference. So we'll do that, and then ultimately publish this model. And in just a couple minutes, what this does is it builds a Docker container for me, and it will push it to a specific Docker registry based on these credentials that I passed through. And since we've set the ARM64 flag equal to true, it will compile this model for ARM architecture, which is important in this case because that's the chip that Raspberry Pis come with. So Chassis can build containers for both AMD and ARM chips, but in this case we want ARM. So took a couple minutes, that's great, and out comes this container that looks like this, right? So in Docker Hub, we've got this container, it's publicly available. This will also be linked, so you can just go ahead and use this container right away. And more to come on this in a second. So we've got our container now, and we've kind of wrapped up step one of this, the flow that we worked through, right? We've built a container out of a Hugging Face model. And now is really where the fun starts. So what I'm gonna do is open up a terminal. Let's see here. Make this a little bit bigger. And what I've done is SSH'd into the Raspberry Pi sitting on that board that I showed you in the PowerPoint slide. Now, remember, so this is a remote device, and I can toggle back and forth between my local desktop and this notebook, and we'll come back to this in a second. The first thing I need to do is download this container to the Raspberry Pi itself. So all I need to do is copy paste this docker pull command and paste this here. Now for the sake of time, I went ahead and did this beforehand. So when I check out my Docker images, I see this Modzy TinyVert model is downloaded. Awesome. So it's downloaded, that's step one. Again, using Docker directly, we're gonna simply run this container. And in this Docker run command, we're passing through the P flag, which will port forward the port within the container to my local host. And then very importantly, we're gonna specify some memory include this memory flag. This is important because this is a 1.6 gigabyte container, but to run it really only requires about 200 megabytes of RAM. And given I'm constrained in terms of resources on my Raspberry Pi, I want to be careful about how much memory I allocate this container. So I've got a Docker stats running over here. We see that there's a limit of 200 megabytes and it's slowly spinning up. And in just a second, we see that it's serving on port 45,000. Now at this point, again, I talked about how you might use curl to interact with the container. We could do the same thing, but what I'll do instead is just run a Python file with some gRPC client code to interact with my container, just to show you directly on the Pi how you can actually run this. So there's got some text in this file, and we see a very similar output that we've seen in my notebook. Again, you might use a specific gRPC curl-like library to make curl commands directly on the Pi itself. If I go back to the server side, we see that it completed the call to run route. Awesome. So this is one way to interact with the container once it's running. So keep in mind, the container is still running, right? And what I've done, I'm going to go back to my Jupyter notebook and go through this first portion of interacting with that container. Now, I've built an SSH tunnel so that anything that I call to my localhost 45,000, again, on my local machine right here, it will pass through to the port that's being listened on in the remote device on this Raspberry Pi, again, port 45,000. So let's go ahead and execute this code right here. Using the gRPC Python library, you can actually generate code, this client code I keep referencing, to communicate with the container directly. So that's exactly what this is. We're basically, from the protofile that defines a gRPC server within my model, we can use that to communicate via remote procedure calls, which you can think of as just simple function calls. So what I've done here is basically constructed a single function that will first instantiate connection to the gRPC server using this Modzy model stub over a gRPC channel, and then invoke a couple function calls or RPC calls to this container using some of these utility request generators. So the first thing we'll do is make a call to this status remote procedure call or function, which simply loads up our model. And then we'll make a call to the run RPC, which sends some data through for inference. So we've got our function call right here. And then what I'll do is pass through each of these 3 bits of text to see how the model responds. And in doing so, we get a bunch of logs out right here. So we see, the first input, today's a beautiful day. The top score is joy. The second, I'm very sad. It's, sadness. And then the haunted house was terrifying, return, a fear as that top prediction. So if I go back to my Pi, remember, we're just simply running this container on the Pi. We see more logs here from the server side. So the server is now returning, status route, status route, status route, and then run route, run route, run route. So it ran 3 inferences, which is great. And this is one way that you could take, a model, from its Hugging Face state, very quickly containerize it, spin that up on the Pi itself, and make inferences against it. So you could take this code and you could build a custom application. And again, with SSH tunneling and all sorts of different data, you could build a pretty comprehensive, application with your single model running, in this way. Very, very straightforward. So I'm going to kill this and clear this out. And now what we're going to do is show the Modzy way, right? So an alternative, this second fork of how can we basically do everything we just did using a COTS tool. And to do so, I'm going to run this Modzy command. Right here, that will use a binary that we call Modzy core. I've downloaded this directly from my Modzy environment. And serve up this same model that we're running. So as we see, some of the logs coming from Modzy core, it found a running container. It's that same one that we're just working with. So basically, Modzy core is doing everything everything for me right there, right? And so I'm listening at port 55,000. And what's great about this is now I can use Modzy's APIs instead of having to, generate my own gRPC client code. So now that this is running, I've also created a second SSH tunnel listening on port 55,000. So I'm going to go back to my notebook again. And what we see here is this Modzy Edge APIs section, right? And so using Modzy's Python SDK, I'll connect to the client, again, through this SSH tunnel, specify a model identifier and version that I'm going to hit, again, serving on my Pi. Pull, 10 different random reviews from an Amazon dataset that I have saved locally, and then run them through the model. Now, the difference here you see is instead of running all this code right here, right, which is accessing the container directly, what we've done is built some APIs that facilitate the same type of interaction through an inference lifecycle. So the first is we'll actually submit a job using this submit text method. We'll block that job until it's complete and then return the results. So in this case, we'll just print the results out directly to my notebook. And as I print this, we see that we're getting results very quickly, right? So the SSH tunnel is fortunately strong and the networking is great. But in addition, the model runs very quickly. And so we see some of these outputs directly from Modzy. Again, we're on the client side here. If I were to go back to my terminal, I see all these API calls that were made, right? So a little bit ago, we had the model running right here, and now we've got all these logs indicating that a successful inference runs. So this is useful in and of itself. I can take these APIs and do this with any set of models, right? Network permitting, all I need is a model identifier and a model version, and I can run this same set of, these 3 lines of code in any application. Which leads me to the next, cool application we've built that will basically wrap these APIs and some of this Python code into a Flask app. So now, imagine I've got my own Jarvis, and we'll call this an intelligent application that allows me to submit some text. And what this will do then is take that text and through that SSH tunnel, send the text over to Modzy core, listening on the Raspberry Pi. It will process the inference through that model and return the results directly to my browser right here. So again, I've just got this Flask app running locally, and let's pass through I love chocolate text and see what the model gives back to us. You can see almost instantaneously we get these 6 classes back. I could say today's a bad day. Run it again. We see the top is sadness, right? I could say that haunted house is scary. Text again. Are scary. We get yet another output, right? And very quickly, I've built this application that's communicating with my Raspberry Pi. So if I go back to the Raspberry Pi again, we see even more inferences, right? With very, very quick return time. So this is just one way that you could build this, right? And with networks and different applications, different use cases, different types of data, there's lots of opportunity, right, to expand on this analysis. I'm gonna go back to my slide real quick and just close with a couple thoughts here. The one is, as I mentioned, we were running a text classifier, an NLP model on this Raspberry Pi. But given a microphone you may have, you may want to run audio processing models or a camera and have some sort of computer vision model sitting on that Pi to build, very custom bespoke applications. So what we would love is any feedback that you might have and any ideas for us to explore to basically take this analysis and turn it into a real, world application that can be used by anybody. I'll just close in saying, again, make sure to tune in December 8th. We will post this video to YouTube with a link to the GitHub repo, so any of you can follow along and do the same thing that I just did. And otherwise, we will look forward to seeing you in December. Thanks so much for joining. I really appreciate you listening, and we'll see you next time.